Hi class, in lesson 2.1 you will be learning about prime factorization and factor trees. Learning targets for today: you will determine the prime factorization of a number, understand the usefulness of prime factors, and recognize that each whole number has exactly one prime factorization. Key terms to look for in lesson 2.1: prime factorization, the associative property of multiplication, factor tree, power, base, exponent, and fundamental theorem of arithmetic. Please turn to page 52, problem 1, dimensions of a tank. Previously, you determined dimensions for display cases using factor pairs. Let's consider other ways to represent the factors of a number. The think tank designs and creates customized tanks and aquariums for oceanographers. A team of oceanographers who study the characteristics of plankton requested a tank that has a volume of 240 cubic feet, but they didn't give the dimensions of the tank. You have been asked to help the think tank list possible tank dimensions using the information about the tank's volume. Recall that volume is the amount of space occupied by an object. The only rule you need to follow is that none of the dimensions can be 1 foot. To calculate the volume of a tank, multiply the tank's length by its width and by its height. Please answer number 1 with your group. For number 1, here are possible tank dimensions for the volume given: a 4 by 6 by 10, a 12 by 5 by 4, and a 15 by 2 by 8. If your group had different dimensions, please make sure when you multiply the length times the width times the height that your product is 240. Please turn to page 53 and answer number 2 with your group. For number 2, you can start off with any factor pair of 240. For example, 4 times 60. After that, you can then determine another factor pair of 60, which could be 6 times 10. You can check your answer by multiplying all 3 factors. For number 2, you can start with a factor pair of 240. An example could be 4 times 60. And then you can determine another factor pair of 60. An example could be 6 times 10. You can check your answer by multiplying all 3 factors together to make sure the product is 240. Composite natural numbers can be written as a product of prime numbers. For example, 4 can be written as 2 times 2. Taking that into consideration, please answer number 4 with your group. For number 4, here is the product of prime numbers for the first row in my table, the second row in my table, and the third row in my table on the previous page. What we should notice is that each product is going to end up having the same factors. The factors are just in different orders. A natural number written as the product of primes is the prime factorization of that number. Prime factorization is the string of factors that is made up of all prime numbers. Please answer number 5 with your group. For number 5, order does not make a difference because when you multiply all the factors together, you are going to get the original number. Recall that the commutative property of multiplication states that changing the order of 2 or more factors in a multiplication statement does not change the product. For instance, if we look at the example shown, 3 times 5 is equal to 5 times 3 for a product of 15. Please turn to page 54. The associative property of multiplication states that changing the grouping of the factors in a multiplication statement does not change the product. For any numbers a, b, and c, the quantity of a times b times c is equal to a times the quantity of b times c. For example, let's look at the associative property of multiplication example that they have for us. The quantity of 2 times 3 times 6 is equal to 2 times the quantity of 3 times 3. 6 times 3 is equal to 2 times 9. We get the same product of 18. Please answer number 6 with your group. For number 6, the difference between the two properties is that the commutative property of multiplication states that changing the order of the factors does not change the product, while the associative property of multiplication states that changing the grouping of the factors does not change the product. Please answer number 7 and 8 with your group. For number 7, when you rewrite the set of factors using the associative property of multiplication, for letter A, we should have 3 times the quantity of 4 times 5. Letter B, the quantity of 6 times 5 times 3. And for letter C, 2 times the quantity of 3 times 5. For number 8, letter A, your product is 60. You could have used the set of factors that you rewrote. It would have been easier to multiply 4 times 5 first, then multiply by 3. For letter B, your product is 90. Again, you could have used the set of factors that you rewrote. It would have been easier to multiply 6 times 5 first, then multiply by 3. And for letter C, your product is 30. You could have used the set of factors that you were given. It would have been easier to multiply 2 times 3 first, then multiply by 5. Please turn to page 55 and answer number 9 with your group. For number 9, the prime factorization of 240 with your factors listed in order from least to greatest is 2 times 2 times 2 times 2 times 3 times 5. Please turn to problem 2 on page 55, factor trees. A factor tree is a way to organize and help you determine the prime factorization of a number. Factor trees use branches to show how a number is broken down into prime numbers. You can use the X or the dot symbols to represent multiplication, but please make sure that you are using one symbol throughout each multiplication sentence. An example of a factor tree for 240 is shown. Let's take a look at the steps. First, we're going to begin by writing the number 240. Then we are going to choose any factor pair, but we are not going to use 1 as a factor. We are going to draw a branch from 240 to each factor as indicated here. Next step, if one of the factors is a prime number, we are going to circle the number to indicate that the branch is complete. You can see that first indicated here. If one of the factors is a composite number, we are going to continue to choose factor pairs, but do not use 1 as a factor again, reminder, until all of the factors are prime numbers. Please turn to page 56 and answer number 1, letters A, C, and E with your group. For letter A, here is the prime factorization for 240. 2 times 2 times 2 times 2 times 3 times 5. For letter C, the prime factorization for 720. 2 times 2 times 2 times 2 times 3 times 3 times 5. And the prime factorization for 360. 2 times 2 times 2 times 3 times 3 times 5. Please turn to page 57. Did you notice that 2 and 3 were repeated factors of the prime factorizations in the factor trees you created? The prime factorizations were long and you had to write a lot of numbers. Because 2 and 3 are repeated factors, you can write their repeated multiplication using a shorthand method. This method is called a power. A power has 2 elements. the base and the exponent as shown. The base of a power is the factor that is multiplied repeatedly in the power. And the exponent of the power is the number of times the base is used as a factor of repeated multiplication. You can read a power in the following ways: 2 to the 4th power, 2 raised to the 4th power, or the 4th power of 2. Please answer number 2 and number 3 with your group. For number 2, letter A, the base is 7 and the exponent is 2. One way to say it in words is 7 squared. For letter B, the base is 4, the exponent is 3, and one way to say it in words is 4 cubed. For number 3, letter A, your prime factorization using powers should be 2 to the 4th times 3 times 5. For letter C, 2 to the 4th times 3 squared times 5, and for letter E, 2 cubed times 3 squared times 5. Please turn to page 58. The fundamental theorem of arithmetic states that every natural number is either prime or can be written as a unique product of primes. Please answer number 4, letters A through C with your group. For number 4, letter A, here is an example of what your factor tree could look like. The prime factorization for 180, 2 squared times 3 squared times 5. For letter B, an example of what your factor tree could look like. The prime factorization for 81 is 3 to the 4th power. And for letter C, an example of what your factor tree could look like. The prime factorization for 48, 2 to the 4th power times 3. Please turn to page 59, number 7, letters A through D. Please answer with your group. For letter A, 24 would be equal to 2 cubed times 3. Letter B, 45 would be equal to 3 squared times 5. C, 54 would be equal to 2 times 3 cubed, and D, 72 is equal to 2 cubed times 3 squared. This will conclude lesson 2.1 on prime factorization and factor trees. Please let me know if you have any questions. Thanks.